All right, there we go. Yeah, as you can see, I'm still chomping away at messages here on my inbox. So I apologize, guys, if I haven't got with those. It's just been one thing after another. It's been an eventful break. We had our PATC trailer stolen and just all kinds of stuff. So it's been a little crazy. So I'll be catching up on those messages tomorrow and get with you guys, and if fix any issues that we have. Okay, so thank you for hanging on with me on that. Anyways, like I was saying just a minute ago, one of our big things on the home front here is that if you go to the website, you can see that the fall schedule is up. And so I'm going to type in auto right here, and you'll see a whole bunch of stuff here. I'll get the ARC. So you see some collision stuff that's up, but all kinds of, I guess I better search it just for AR because it's picking up all kinds of stuff. So we'll go semester, fall, subject, AT, there it is. That should get us pretty cleaned up. Yeah, so you can see all the stuff we're running this fall. Now, what we're doing right now, at least the thought process for right now, is that we're likely going to be trying to keep our class sizes small and even maybe further divide that up. So you can see a lot of these classes like brakes classes like brakes is one of our core classes, right? It's an ASE certification area. And because of that, it has, hands-on activities and areas where the instructor has to evaluate how you're doing with your hands-on skills, right? And remember that our school is an ASE Master Certified Program. So that's part of our certification, is that we can watch you guys work on stuff and evaluate you hands-on. So classes like that, we haven't been able to run. We are looking to run that class again with a smaller class size. We might even be like splitting you up into like a group A and a group B. So we might work with 8 of you at a time, something like that. So what I would say is if you sign up for any summer classes or fall classes, watch for emails coming from your instructor, because there might be like some special instructions on how we're going to like divide up the classes, that type of thing. Like you can see this one right here. It says partially online. Well, why does it say that? Because we're looking to put the lecture type information online and really focus for our in-person meetings to be for the hands-on component of the class. So that's been my big stressor in the last days and weeks, is trying to get these schedules online and up and running. And they're not perfect. They're kind of like the best compromise I can come up with as far as keeping social distancing, keeping you guys safe, and getting our hands-on in-person part of our program up and running again. Okay, so anyways, we're excited to be doing that, and we should have in-person classes running for here. This is obviously looking at fall, but also for the summer as well. Summer's going to be kind of our test case. Now, a lot of stuff's changing, right? People are getting vaccinated, and this might open up sooner. And so stuff might continue to develop and evolve, and we might be able to add more classes, but this is where we're at right now. So anyways, let me change this back to our dashboard here, and we're going to open up our AT181 meter class. And at this point in the meter class, we're kind of getting to where we're kind of starting to wrap things up, right? It's only a 1-unit class. I've already given you like 3 units worth of information. So I'm trying to wind this thing down. And what you're seeing is that the 181 class is kind of winding down, if you will. And the 188, the standard class, is gonna start ramping up. So let's look real quick. I'm going to put my student view on. Let's look at like what we have that's coming up that's due, right? And so I always say, hey, always check out your class announcements to make sure that you're up to speed on whatever's going on. And of course, if you guys are here with me, you looked at this class announcement right here, so you're up to speed on that. So you guys probably got it, but you always look at those announcements. And then the other thing I like to do is go to the what's due. And in fact, when I look at that, there's a couple things that I need to fix on here. Now, okay, so we got the horn circuit part 2, which is correct. And this one, I need to move this out. And that one's correct. Okay. And then some of these we're gonna spread them out a little bit, but we're kind of getting to the very end of this thing. So because originally I intended for this to be like an 8-week class, right? Well, what I ended up doing is instead of all of our Zooms being like an hour and a half long, some of our Zooms were only an hour long. And so that kind of stretched out to maybe about 10, 11 weeks of information. But we're kind of winding down. So anyways, you're going to end up with 2 things this week, this thing on the horn circuit and this other one, which is just a little lab on electrical knowledge. Let's start with the horn circuit one, guys. So what I'm going to do is I'm going to go ahead and click this thing and open it in my student mode. So a few weeks ago, I don't know if you guys remember, but a few weeks ago, you guys were supposed to go to your car, look up the horn circuit, submit a wiring diagram of that horn circuit, and basically find where's the horn relay on your car, where's the horn fuse, that type of thing. Okay, this is kind of a continuation of that. What you do now is, now that you've already figured out, hey, where's my horn relay and stuff, and where's my horn fuse, you're going to test for voltage at the fuse, you're going to test for voltage at the relay, you're going to do a little relay swap and see if there's another relay that can be swapped in place of that horn. And then this is one of the few times that in our class, we're going to use our meters to measure some current flow. And the reason I picked the horn circuit is, 1, they're all pretty darn similar. 2, they're usually accessible. And 3, they usually draw somewhere between 3 to about 4.5 amps or so. And so that's a good amount of current that's safe for even the cheapo Harbor Freight multimeters out there that max out at 5 amps. And so it's a great way for us to practice measuring current flow with our meter. And so it's essentially the first part of this activity. What you did is you found the stuff, you pulled the wiring diagram, you kind of figured out what you were looking at. Imagine this is our diagram right here. Part 2, you're going to actually use your meter for some measurements. And on most cars, the horn circuits are pretty accessible, and they're it's not a circuit that's going to cause a bunch of problems. It's generally a pretty straightforward circuit, even on a fairly late model vehicle. And so that's why I picked it. And so what I'm going to do real quick to give you an example is let's look up something kind of new. We're in here. I just opened up ShopKey Pro. We're going to let's see, what was somebody was looking up 2018 Silverado. Okay, that's pretty late model, right? They must have been looking at something about the brakes, but I'm going to type in horn in my search bar here, and then I'm going to click horn, and I'm going to click wiring diagram, and boom, this thing will take me to the horn diagram. And so here we're looking at a pretty late model. In fact, I'm going to click it again and get it where I can adjust the zoom here, guys. We're looking at a pretty late model Chevy Silverado, right? This is a truck I'd like to have right here. And you can see they have hybrid and non-hybrid models. And we can see that there's a body control computer in there. And there's some, you know, fancy stuff with the airbag clock spring and stuff. But, you know, here, it doesn't matter how new this thing is. You know, at the center of this circuit, there's a horn relay that's pretty conventional, right? There's a fuse, underhood fuse block, so that would be very accessible on the car, and it leads up to a couple of horns. So I don't care how new the car is, and if there's a body control module there or not, the majority of the horn circuit is pretty straightforward. I mean, what's different about this than something older is that when you push the horn switch on your dash, right? When you push this switch, essentially what you're doing is you're providing a ground that goes to the body control module, and you've made a request. You said, hey, body control module, I'd like to make the horn sound right now. And then the body control module says, okay, I will then activate the relay, and then that can give power to the horns, right? So at the center of a horn circuit, you're always going to have that horn relay. And so it's a pretty common and conventional circuit, no matter what car you're working on. So it gets you guys used to testing relays and voltages. It's a great one to do, and that's why we're doing it. So that's kind of like your primary kind of hands-on, so to speak, activity to do in class is testing out that horn relay. Remember that I made a video clip of testing out horn circuits, and I took a Toyota or a Lexus, and I tested out those horn circuits, you know, 27 different ways. Let's see if I can get back to it and find it. If I go back to our course, and I'm still in my student mode, so, and if I go back to announcements, so this was actually, I put it up there a few weeks ago. So here is a video clip I made on testing the horn circuit. I'll go ahead and click that thing. And there's my big ugly face talking about horn circuit testing. So anyways, I even show you the video or the wiring diagram on that thing. So it'll give you a good example of what you guys are to do for your horn circuit activity. Okay. The other thing, in fact, let me go back to that thing. Let's go to calendar. Chassis diagnostics horn circuit. And then what I'm going to do is I'm going to click start assignment. So for this one, it does say, hey, take a picture of that reading showing your connection. So there is one picture that you submit for this. And then the other stuff, you know, it says record your readings. Well, what I like to do for this is I'll take this and I'll Control C, I'll copy the text. I'll go to text entry. I'll paste it, and I'll start writing down my readings. So maybe I test the relay, and it's, I don't know, 70.2 ohms, right? And I'll put, hey, that was my reading right there. I'll make that a color or something so it pops out. Anyway, so it makes it really easy to write down, these are your readings, these are your answers basically, and then I can click submit. And then you can also go in there. Sometimes you have to do a new attempt. Other times you can put it all together in one, but you could always go in there with another attempt and say, hey, I want to add a file. And this is where I could add my photo to this thing, okay? So that's doing that horn circuit. And in some cases, I know in distance learning, it's harder to submit the darn assignment than it is just to do it, but that's where we're at right now, right? Now, the other thing, if I go back to that calendar, that is going to be due is this little lab quiz sheet. And it's just basic meter knowledge. It's 5 questions. It's pretty basic. It's ASE style, and it's questions about using your meter, right? So it says, which measurement of electricity actually does the work in electrical circuit? We've talked about that quite a bit. And remember, my thing is like, hey, if I was getting electrocuted, what stops my heart, right? It's the current flowing through my heart, right? Remember, whenever you're doing technician A and B question, you split them up into 2 true false statements. Here I got a student A and a student B. So again, 2 true false statements. So there we go. That one, here's one on batteries. And then of course, we have to have a question on relays. It wouldn't be complete otherwise, right? So that's the other thing that I'll do this week. And what I'm going to do is I'm going to go back to that course calendar, and I'm going to leave my student view. I think I'm going to try to leave my student view. Again, I don't know why it's not letting me move. Okay, let's try it. Let's do this. Let's go back to our. Boy, this thing's acting all kinds of weird. There we go. Okay, it's just a little locked up or something. Okay, so here's our multimeter course. I'm going to go back. Nope, I'm going to go to this. I see your email right there, Sam. Come on, but we're going to go to this, and this one I'm going to move. So, because I don't want to tackle that this week. We're gonna lead up to that. First of all, I have to edit some video footage that I took, and 2, I'm gonna do some more modifications on anyway. So your class is the one that's blue colored. So it's the horn circuit part 2, lab quiz 4, which is what we just looked at. And you notice that there's those ASE style questions on this lab, right? Like I keep giving you these ASE style questions, and I say on here, hey, remember that you want to select the most correct answer for each question. Remember, that means that you could see 2 answers that look pretty darn good. One of those questions or one of those answers is going to be more correct than the other one. Okay. Now, some of you guys,
the way I think of it is which one of them is less of an idiot.
Okay. That's good. That's, I mean, we have to kind of do what works for us, right? So you've learned that, hey, if you think of which guy's less of an idiot on there, then that's a good testing strategy if that works for you. I like it. So I'm pushing up ase.com real quick because I know that, hey, some of you guys, you might hate these ASE questions, right? But the reality is, I know if you want to be a professional technician these days, you're going to have to get good at taking ASE tests, whether you like to or not. It's kind of just something that we have to do. One of the things I just recently did, which I thought was kind of fun and I wanted to share with you real quick, was I have several ASEs that are up for renewal, right? And the testing window is still closed. I think in a few days, I think maybe mid next week, they'll open up ASE testing for the spring. But the test centers have been closed off and on due to COVID and all that stuff. So ASE came up with this thing for Ase Renewal, where you can renew on your cell phone, and it's kind of a neat thing. So you can renew on your cell phone with the app or an iPad or something like that, or you can do it through your computer. I did some of the questions on my computer, and what they do is they basically send you an ASE test question in every area, and then next month they're going to send me a few more, and then next month they're going to send me a few more. So you think, oh, well, couldn't you cheat on this test? Like you can look up answers. You can't normally do that. And yes, you can, but you only have like a 2-minute timer to look up any answers on the questions, and they make the questions harder. And you might be thinking, what if I just have somebody else take the test for me? Well, because they give you like one question a month in each ASE area, they feel like it's kind of spread out over. So, even if maybe you had somebody fill in and cheat for you one month, they might not be there the next month. And anyways, it's something new that they're trying. So I signed up for this thing, and I did get a couple of electrical questions that were kind of fun, and I wanted to share those with you. And so remember, like, part of my job as your instructor, is to help you, guys get ASE certified yourself if you want to be a professional tech, right? And so, okay, we got those up. I'm going to change my screen share, I think. Here we go. New share. Here we go. Let's clear out some of these drawings. All right. Okay, so the one that was the most straightforward really was this one right here. And we'll get that guy up on the screen. All right. And so, I like this question. Straightforward. I think this was one of the pre-test questions. Before you could qualify to do this thing, they gave you like a set of, 3 or 4 or 5 test questions to try at the beginning to see if you could do it, I guess, was the idea. And this is a good example of what you would find on your ASE test in electrical, the A6 test. So it says the delay windshield wiper settings do not function. The meter readings shown were observed during diagnosis, which of these could be the cause, right? Whenever you're doing these questions, always use your process of elimination here, because you don't have really you don't have every different scenario under the sun. You have an open at W, an open at X, high resistance at Y, and a short to power at Z, right? I mean, those are the different things that you have. So, what I will do is I'll just usually kind of go on here and start playing out these different scenarios, right? So I'll start here at the bottom and say, okay, well, if I had a short to power, right? I don't know, maybe it's 12 volts or something here. Well, that doesn't really match these meter readings, right? Because then this guy here should say 12 volts and he says 5 volts, and we see that the body control module gives this thing 5 volts. So that doesn't really compute. High resistance at Y. So I'm going to change my color now. And I say, okay, if I had high resistance right here, I'm going to draw like a resistor there. Well, with that definitely can make this thing act weird. But again, it doesn't match these meter readings. In fact, if I look at just the 2 meter readings, let me erase this out of here. And I'll switch that over. I'll see I have 5 volts on this wire right here, and I'm giving it the green thumbs up because the way I look at that, it's supposed to be a thumbs up right there. He's putting 5 volts on this line, and that's what I should measure there, 5 volts, right? Now, I see I have a resistor here. It's a variable resistor, and then it goes to ground, right? And this guy, the way it's drawn, is right in the middle. Now, I know realistically it wouldn't be right in the middle, but based on the way this thing's drawn, on this meter right here, and I'll circle him in a different color, circle him in pink here, I would expect somewhere around, 2.5 volts, 2.5 volts, right? But, realistically, maybe he's down around somewhere between, you know, 0.5 volts and maybe 4.5 volts, somewhere in this range of 0 to 5. I'm just kind of giving it a medium number. I certainly wouldn't expect it to be 0 though. I would expect a little something on it. Okay. So do I think I have resistance at Y? No, in fact, if I really look at these meter readings, that doesn't make sense. Okay. This doesn't make sense either. And you know what makes the most sense here is this one, an open at W. Why? Because if this was open right here, then that 2.5 volts I'm figuring, or somewhere in this range, wouldn't actually get to where this meter's back probed, and that would explain why I would have 0 volts on that meter. It would also explain why the delay function of the windshield wipers wouldn't work, right? So I like that one. That's why I circled that one green. But whenever I'm taking a test, I always try to look at every single answer and really process of elimination and really weigh things out to make sure that I am sure that I am selecting the most correct answer to the question. So I'm going to come back to this one where it says open at X and say, okay, well, what would happen there? If I had an open right here, what would I expect to see on that meter there? What do you guys think? If I really did have an open circuit where this guy was disconnected right there, what would you expect to see on this meter right here? Would you see 0 volts? What do you guys think?
0 volts. 0 volts.
So I got some votes for 0 volts, and so this is why I wanted to bring this up. That's actually not correct. Okay, and don't worry about it. That I'm glad you guys played along. Okay, here's what's really going to happen, and it's
not
kind of like
ground.
It's a head scratcher, right? Well, you're like, hey, there's ground.
Another ground.
There's ground right there, guys. It's grounding through the.
Yeah. I didn't see the second ground.
Yeah, electricity.
I didn't look it through.
Trying to find a path to ground, right? It's always so. What would happen is it's kind of like the 5 volts would feed out. It would go through here and go through to that, and so this meter would also say 5 volts. So if the scenario was the delay didn't function correctly, and this meter read 5 volts and this one also read 5 volts, I would say, oh yeah, that open at X, but it doesn't say that. So anyways, yeah, so when you lose ground, weird stuff happens. In fact, that was real common too back, like your older throttle position sensors that were an actual potentiometer. If you lost the ground to the TPS, the computer would think you're at wide open throttle. Or even if you had high resistance on a TPS ground, it would think that you're opening up the throttle more than you actually were, and it would cause the engine to run rich, all kinds of stuff. So anyways, this was a good little test question, and it really got you kind of thinking about like, what's going on with these meter readings and how would it work? And I mean, these questions aren't always perfect. They are designed to get you thinking. Okay. I'm going to give you 2 more questions real quick, and to do that, I'm going to switch this back to my file folder. There we go. And we're going to open up, this one. Ooh, not one. This is a good one. It's not as there's no pictures, so it's not as fun to look at, but it's a good question. The engine has an intermittent, let me make sure I'm sharing it correctly. Yep, okay. Engine has an intermittent slow crank condition. The DMM is connected between the starter body and the negative battery post. The DMM measures 1.3 volts while cranking. The cause could be. Now remember, my rule, what we're doing is we're measuring VD, right, voltage drop on the ground side. And for a starter, I really want this to be like, 0.5 volts or less, okay? And remember that voltage drop, guys, what does that equal? That equals resistance. So if they're saying, hey, you got a slow crank, well, that would make sense because I'm adding resistance to the mix. And we're measuring not 0.5 or less, we're measuring 1.3 is what the test question says. Volts on between the starter body and the negative battery post. So we're measuring 1.3 volts on the ground side for a voltage drop, which is too much. Okay, so I have too much resistance on the ground side. Now, why would it be intermittent? Like you'd think it'd be, yeah, well, yeah, these questions aren't necessarily written perfectly. So, maybe every once in a while it's got 1.3 and the negative battery cable wiggles or something, and that gets lower or something. If the cable moves a little bit, but, regardless, 1.3 volts is too much. That could definitely cause a slow crank. So, I look at that and I go, okay, well, what answer here makes the most sense? A loose connection at the positive battery terminal? Well, no, we got high resistance on the ground side, so I'm not going for that. High resistance negative battery cable, that lines up with this, so that makes sense. Warm crank relay contacts, no, that doesn't make sense. And corrosion on the positive battery cable, does that make sense? No, again, so the only one that makes sense is this one on the negative, so I'm going to go for that one. So hopefully that makes sense. I got one more here that should be pretty straightforward and make sense. All right, so new share, let's see here. We're going to go to this one. I can't remember if, yeah, I think this was for the air conditioning recertification. And so why I wanted to point this out to you guys, and I'll zoom in on it and make sure I'm sharing the right thing. Yep. Let me zoom in on it now. Too much necessary zoom, I guess. Okay, so take a minute, check out that question. It's for the AC test, and they're talking about putting an oscilloscope on there. And the point here is, like, if you can understand electrical, you can pass a lot of your ASE tests, because every single ASE test has some electrical questions to it. All right, give me just a second. My garage cat is freaking out. We're going to kick it out, and then we'll answer this question. All right. So the oscilloscope waveform is observed with the oscilloscope channel lead converted or connected to the AC compressor control circuit. Which of these represents the duty cycle of the solar array? So this is really a lab scope question, but they've figured out a way to apply it to the AC compressor. So I guess it became an air conditioning question, but I thought this would be a great way to introduce you guys to oscilloscopes. And actually, one of the things we're working on is to put together a class like this, kind of an online class that's all about using an oscilloscope. And I'll show you the oscilloscope that we're gonna get for the class. It's pretty cool. So essentially, what an oscilloscope is it's like a voltmeter with a TV screen so that I can graph the voltage on the vertical scale here over time on the horizontal scale, okay? So it's voltage over time. And so what this one, it's going up to 12 volts. So it has 12 volts up there. And then it looks like we have 4.5 milliseconds. So just fractions of a second going across the screen. So what an oscilloscope does is it's able to graph voltage over time. Now with pressure transducers and other things, you can graph other stuff over time. Like I could put this low amps probe in there and I could graph current over time. Or I could put a pressure transducer on there and I could graph out the pressure over time. Anyways, it's like a meter with its TV screen, so you don't just get to read the numbers, but you get to see what it's doing. And I found that it really helped me understand how different automotive circuits worked because I could see what type of signals they produce, okay? Your multimeter tends to average out numbers. Oscilloscopes scan their readings much faster. They sample, they have much higher sampling. And so because of that, they are able to they are able to catch glitches and things that meters may not catch. Okay, so I got a comment in the chat. Hey, is it 25%? You know, that is a good, like the oscilloscope lead is connected. Which of these represents the duty cycle of the solenoid? Well, duty cycle is one of the things that we were going to talk about tonight. It's one of our advanced meter functions. So if you have a really expensive fluke meter or snap-on meter, or, you know, a lot of those meters will have a duty cycle function, right? You won't likely find it on your Harbor Freight meter, but you'll find it on a more expensive one. Well, duty cycle is, duty cycle, that is basically a percentage. So there's my percentage of on time. So how long am I on, right? So if I'm on 100% of the time, that would be one thing. And then if I was off, you know, so then you go, okay, if it's percentage of on time, well, let me get my bearings here. And at first, you know what, 25% sounds good to me because, you know, you figure, okay, well, if I was on 100% of the time, you'd think, okay, well, I'd be up here. And if I was off 100% of the time, I'd be down there. And I can compare the, and if I was 50-50, right? Because that's one of my answers. It would be like 50% up here, 50% down there, 50% up here. And so you go, okay, well, that would be like 50-50 would look like this, right? So you start going, yeah, like 25% seems right. But here's what's critical on this question. You really have to look at how they have the scope hooked up. So they have the scope hooked up with the positive lead right here being connected to the AC compressor control valve. And the AC compressor control valve, what is he controlling? Right? Just like on the last question, it's really important that you look inside the gray box. Oh, he's controlling the ground. It's a duty cycle on-off signal to control a path to ground. So when this wire is grounded, it is on, okay? What's coming on the other side? The other side is power coming in. So when the computer, in this case, the HVAC control module, provides a ground to that valve, it turns on, right? So it's you got to think, well, what is on then? Well, what that means is the way this is hooked up, when the voltage is low, this is actually on. If I take away the ground, if I take that away, then you know what I'm going to measure right there? I'm going to measure 12 volts. So that means that this is off. Oh, okay. So on is low and off is high. Okay. So what that means is, nope, it's not 25%. It's actually 75%. Yeah. Good job there on the chat. Yeah. Very tricky. You really had to look, well, how did they hook that up? Okay. Most of the time we're going to hook up our oscilloscope to the ground side, and the computer is going to control the ground. So the low, that when the signal is pulled down to 0 volts, that's on. And when the signal is up at 12 volts, it is off. Okay. Yeah. So pretty advanced electrical oscilloscope question. And they had it for the air conditioning recertification. Like I said, this ASE recert deal is they're giving you harder questions than you would even normally see in a regular ASE test. And so I don't know, I thought it was pretty cool. I was like, oh, those are tricky. They're trying to outsmart me there. So anyways, pretty fun stuff. So I was feeling pretty good about this until I saw this next question. And it was really like one of the first times I can remember, at least in a long, long time, on an ASE test where I was like, what are these guys even talking about? So let's go back to this. We're going to select that. And I'm going to bring this thing up. Now, I read this question and I thought to myself, these guys are making stuff up or something, because I was not familiar with this. A vehicle has an intermittent flex ray communication fault during diagnosis with an oscilloscope. And this was under the engine performance ASE recert, by the way. The technician performs a flex ray eye diagram mask test. During the test, you randomly see this on your scope screen. And it was like, oh my goodness. Like, I didn't even know if flex ray, it sounded like something that was totally made up. Okay. Well, I basically had 2 minutes to do a little bit of research. And so a quick Google search allowed me to verify that, a flex ray communication is a real thing. And turns out that it was used by some European manufacturers in like the late 2000s to maybe early 2010s. And they looked at it as maybe a faster network than controller area networks. And by the way, this flex ray IMS diagram was a real kind of diagnostic thing you do on there. Now, I didn't pull all that in 2 minutes, but I did verify, within a few seconds that, oh, okay, well, this is a real network that you could find on some cars. And the eye diagram mask was a pattern that you could get off of it for diagnosis. Okay, so I verified that this was at least real. And then I did process of elimination. And so my process of elimination was this. If you had, let's say you had a wire shorted to 12 volts power, I would expect it to have a line at the top. And if you had something shorted to ground, I would expect a line in the bottom. If I had wires shorted together, my thought is that it might be like pulled to the center, because a lot of these things like it'd be at 2.5 volts in the center. So I didn't think I had this. I didn't think I had that. I didn't think I had that. And then I came to high resistance. And so the lesson here is, guys, is that when you have high resistance in an automotive circuit, like weird things happen, okay? And so stuff doesn't do what it's supposed to do. And cars will do all kinds of weird things. Like you can have a high resistance in a tail light connections, and now your blinkers blink real fast or don't blink at all, or all kinds of. So anyways, I looked at that and I saw all these crazy lines and I said, you know what? That looks like something weird, and high resistance issues often create weird complaints on the cars. And I went for that one, and that did turn out to be the right answer. So anyways, I thought those were kind of fun. And like I said, I did not know about flex ray automotive networks before this ASE test. And then after I took the test, I was like, oh, I want to research this a little bit longer and figure out more about it. So kind of interesting stuff. All right, so let me, I need to pull this back to our class. There we go. And we are going to I'm just kind of cleaning up some stuff on my computer screen, guys. So give me just a moment to do that. There we go. All right, and I'm going to go back to our class, and so we've gone over what's due this week. I'm going to go to modules now, and basically, like I said, we're winding things down. We're winding things down, and so we pretty much have gone all the way through these 8 weeks, like we talked about. Charging and starting system diagnostics. Here's the horn circuit part 1 and part 2. We actually, before spring break, we did our case study on the no start condition. I have a few other activities with fuel pump diagnostics and stuff for you to do, but we're pretty much at the tail end of this thing. And so the big thing will be, and this is kind of self-paced here on the Snap-on stuff, because the way I set up the points for this class, I knew that some of you guys would be really interested in getting Snap-on certified, okay? But when I talked to the school about setting Snap-on meters up for checkout, when the school realized, oh, every Snap-on meter is like $450, they're like, oh no, you're not going to check out $400 meters to students to have for months at a time. So the problem with the Snap-on certification is I felt bad. Like, it's hard, you know, it can be hard to certify a meter that you don't get your hands on. So what I did is, if we go all the way back to the syllabus and go to like grades and stuff, is that the Snap-on certification is extra credit. Okay, so you don't have to do the Snap-on certification, but I knew that some of you would want to. And so what I've done here is I go back to our modules, and some of you guys, I still need to enter in the Snap-on system. I think what you will find is even without the Snap-on meter in your hand, right? Here I have the manual there for you, which is a little bit, you know, it's a little bit dry, but you know, it's always good to have the manual. I have, if I go back, on top of the manual, I have the actual Snap-on PowerPoints, and I have a little overview that explains how everything's set up. But I have the Snap-on PowerPoint, and I've broken it up into different units or segments in there. And I'll just click that because it takes forever for it to load in the fast view window for whatever reason. It should be like slow view window. And let me change my screen share so you guys can see it. Here it is. All right. So there's the Snap-on meter. And I have the whole presentation in there for you. But that's pretty dry, pretty hard to learn from. So what me and Mr. McCormick did a few years ago is we broke this down and made it into a bunch of videos. So if I go back to, where is it? There it is. I go back to our Canvas page, and back to modules. Basically, I have videos here for every single module. So, and some are Mr. McCormick narrating the video. Some of them are me narrating the video. So I'll open up one of these videos.
Unit 3. When you complete this unit, you will
All right, so there's Mr. McCormick narrating that
insert
video.
red
Anyways, so you can watch the videos and kind of follow along. Ultimately, what that's going to do, if I go back on this thing, is you can go through all this, and I set it up to be like match up with the rest of the weeks of our course. But ultimately, what it does is it will take you to a pre-test. And what I would tell you guys is practice the pre-test a bunch of times. You should be able to take it over and over and over again. And when you get to the point where you can pass the pretest with a 90% or better, then you're ready for the actual test on the NC3 website. Okay, think of this NC3 website as like it's Snap-on's website, if you will. Okay, that's not 100% correct, but it's not really controlled by me. It's really put together by NC3, stands for like National Certification Center. It's essentially it's Snap-on. Okay, and so you only get 3 attempts on the Snap-on website to pass your certification. So you want to get to the point where you can kind of ace the pretest. Once you're acing the pretest, then you can go on NC3 certs and put in your basically your school email is your login, and your password. I default set everybody's password to password 1 here, and that will get you to log in, and then you can get certified in the Snap-on meter. And if you get that certification, it makes like a PDF document. You can save that thing and submit it, and that'll get you your 50 points of extra credit. And what I found from last semester doing this course is most students that were pretty comfortable like using the basic meter that they had, whether it was one they had at Harbor Freight Tools or they bought at the auto parts store or a Fluke meter, like if they really understood how to use their meter and they kind of read through the stuff on the Snap-on meter and they watched the video, especially with some of the special features like how to measure duty cycle, how to measure RPM, right? Because I'll tell you what, measuring volts, amps, and ohms, that's pretty much the same on every meter, right? It's some of like the particular things like using the min-max features and stuff. Once they kind of watched the video clips on those parts and got to see, oh, that's like the order that you hit the buttons. The folks that were interested, most everybody passed the Snap-on certification that wanted to do it, even though they didn't have the meter in their hand. Like I said, if you know how to use a regular meter and you can use all its basic functions, that's going to get you most of the test questions. And then there's a few test questions that are specific to that Snap-on meter, and you really have to watch the videos so you know like the sequence to press the buttons and that type of thing. But if you watch those video clips, you can pass that. So what I've done for you guys in the class is I've set up all those presentations and the video clips there for you, the manual, and there's a few other resources when it comes to the Snap-on meter. And so that's why I broke it down into weeks, but you could probably sit down and, within a couple of hours kind of study through that thing and take that test. So that's kind of like essentially that's like, that's the extra credit part. But the other thing that the final exam for this class, which isn't due till the end of the semester, isn't due till May, but it should be open now, it's kind of like all those little 5-question quizzes that we've done. You take them all together and you put them all together, and that's what makes the final exam on this class. And it's ASE style. And again, the idea is that this prepares you for getting ASE certified in electrical and testing your knowledge of the meter. I have in here, hey, this test is open book, and we encourage you to use all the resources and stuff. So anyways, hopefully that makes sense with the resources and stuff. I have for you guys. Let's see. Well, I'm running a little bit. I guess I spent too much time going over those ASE questions. What I did want to do was talk a little bit about, and we actually did a little bit as we did the ASE test questions, but a little bit about frequency and pulse with this presentation right here. And to speed this thing up, what I'm going to do is I'm going to change this screen share here to this, and just scroll through a few of these things. And this one isn't really specific to the Snap-on. Actually, I used the fluke meter for this, but these are a couple like advanced meter functions, right? So frequency is a measurement of how often something happens. Like when we measure frequency, like sound waves, right? Like you can have low frequency and high frequencies. Low frequency would be like your bass, and high frequencies that you hear would be like your treble, right? And it's measured in hertz or cycles per second, okay? So if you're measuring a frequency of 1,000 hertz, that means you're having 1,000 cycles in a second, okay? Now, I'll give you a great example that's electrical related. We talk about AC voltage coming out of our wall outlets, okay? It switches back and forth, and if I split this up between there, right, and it goes back to there, like essentially that's one cycle, right? Or I could stop it up here and go to there. But if I start up and I go down and I go back to up, right, I've done one complete cycle. Well, our wall outlets operate at 60 hertz. So 60 cycles a second. We have 60 of these happening every second, okay? So if I have an advanced meter, and I'll clear those drawings, if I have an advanced meter, I can measure that that frequency directly by hitting a button or turning the knob to a dial. On the fluke meter, I have to hit the frequency button right there, and then I can measure what my frequency is. Here I'm at 157 hertz. Now, why is that a big deal? Well, some sensors like Ford manifold absolute pressure sensors, those changed frequency as they changed in manifold pressure. So some sensors, like the frequency was a big deal, right? Another one is duty cycle. We talked about this already tonight. It's percentage of on time. So if you have a meter with a duty cycle function, it basically can sample this like the oscilloscope, but it's not going to give you an oscilloscope screen. It's going to measure the off time. It's going to measure the on time. It's going to take those two numbers and calculate this percent is what it's going to do. So how would I do this? Well, I come over there, I hit that button, okay? But then I hit it again. So you can see how you hit it once and it's hertz. You hit it again and it changes to a percentage. So I hit it twice, and now I'm at duty cycle mode. And so if I'm measuring a duty cycle of 50%, that's what you see on my screen right there. And so that's useful for things like canister, control valves, and other things. So not every meter has these abilities, but if you have an automotive specific meter or a more high-end meter, it will have some of this stuff, and it might be a spot where you got to turn the knob to a particular setting and then hit a button, or it might just be a button push or a knob push, or, you know, it's usually a kind of a special function, right? So on this one, it's set to volts, DC, and then I hit that frequency button a couple of times to bring up duty cycle. So that's how those functions work. And sometimes you'll be doing a flow chart for an automotive diagnosis, and we'll ask you, hey, measure the frequency coming off this sensor, or this control solenoid should have a duty cycle that ranges between 25 and 75%. So having a meter that can do that is nice to have. And then you can compare what it says on your meter to perhaps what it says on your scan tool. Okay. So is that a must-have function? No, I don't feel like it's a must-have function, but it's a nice to have function. Every once in a while, it's like you want to be able to measure a duty cycle or measure frequency. And if you have a meter that can do those functions, then that makes it quick and easy to do. If you don't, you're gonna kind of scratch your head. In fact, I'll give you an example with this duty cycle percentage. Let's say I am at a 50% duty cycle. Now let me go back to this image right here. Let me put down some readings. Let's say that this is 12 volts and this is 0 volts, right? Well, if I just set my meter to measure volts, because it doesn't have the ability to measure duty cycle, and I'm at 50%, 12 volts and 0 volts, what my meter is going to do is it's going to average this out. It's going to average out the 12s. It's going to average out the zeros. And it's basically going to show me, oh, I have six volts being displayed on my screen, because that's just how it works. It's going to average out those readings that it gets and say, oh, you have about 6 volts here. Now it might be like 5.5, it might be 6.5, but it's going to take that average. Okay, so by having the duty cycle function, you can figure out exactly what it is. Better yet, if you actually had an oscilloscope, then you could see this image on your screen and really know what's going on. Okay, so pulling this thing full circle. Remember that I said we're working on an oscilloscope class. One of our instructors, Lee, he actually was one of the guys that helped. Let me change my screen share real quick. He was one of the guys that helped put together. He worked for Snap-on and actually helped work on the reflash modules and stuff for the Snap-on scanner and the Veris and stuff. And anyway, so he's helping me work on building a online oscilloscope class where you would go in and check out from the school a little oscilloscope. And I'll show you the oscilloscope that we're looking at. And it's this guy right here, I think. I don't know why it's not working. There we go. It's this little U scope. And so we're looking at getting like a class set of these, and you guys could go to the school and you could check them out. Some people might want to buy one, right? And I know I have some students that have an oscilloscope, but this is a nice little 1-channel scope. And the idea is that you'll be able to test stuff at home. We'll zoom in on that. Didn't really help, did it? Anyways, it's a pretty cool little scope, and we're trying to put together a class on it to teach you that type of stuff, because what I find is oftentimes, like in advanced electrical and engine performance, when I used to teach that course, I spent so much time just trying to teach students how to use the tool that then they weren't necessarily learning the car, right? The idea, even what you're doing right here in this class, like if you're taking this class right now and you haven't taken the automotive electrical class, when you do take that class, you're already going to know some of how to use the meter, and you're going to know some of electrical, so you'll be able to take that class in and process it a lot faster. When you get to engine performance, if you already know how to use a meter and know how to use a scan tool, you don't have to focus on learning those tools. You can really focus on learning the car, right? We use these tools to test the car, but in school, we also use these tools to kind of show how the car works. And if you're fumbling around the whole time trying to use a tool, it's hard to learn the car. And I've found that again and again and again. So anyways, this is one of the things that we're working on, and I'm looking forward to it. And think of this thing as it's basically like a really fast acting multimeter on steroids that can graph the voltage over time across the screen. And I found it personally very helpful because it can help teach me how things were supposed to work. Like, well, I don't know if that's going to vary frequency or is going to vary voltage. When I could see it on the screen, I could figure out what was going on. So, all right, well, let's round this thing up and finish this thing off. So we're going to take a break here in our automotive electrical class as far as Zoom lectures and stuff. I will get with your emails and kind of catch up on stuff. But we're going to take a few weeks off and probably have like one last Zoom meeting in the class to kind of wrap everything up. But we presented most all the information at this point. And now it's just, giving you guys a chance to kind of work on those various assignments and get those things done. I do have a few YouTube videos I'm working on to add, some more content to the class. But we've really covered like the bulk of the information. Okay, so before we wrap things up, I want to open up and see, does anybody have any questions on stuff for our AT181 class? Any questions?
Mr. Frank,
Yeah, go ahead.
how are you today, sir?
I'm doing good. Doing pretty good.
We want to say thank you for all your diligent work getting these semesters knocked out.
Well,
I heard you've had to revision, and it's a lot, and thank you.
Well, thank you very much for that. Yeah, it's been a lot of work, and I want you guys to realize that nothing that we're doing right now with COVID, nothing's going to be perfect. Like, we're constantly changing stuff on the fly, and I just want you guys to be prepared for that. Like, I think as stuff improves, we might be able to loosen up our, whatever we're doing in the class, but be prepared that we're going to have to kind of adjust with the time. So thank you guys for thinking of me and appreciating that. And, I'm just
I do have
back into normalcy again and working with you guys in the shop. That's what I'm looking forward to.
Absolutely. I do want to just tug your ear. I know we're short on time.
Yeah.
There's 22 of us from Leo Gutierrez's class a year ago for 330.
Okay.
And we're looking at 330 being a 8-week class at the end of the semester.
Yeah. I wanted to run
and
more
then
than
it's
that, but I was limited on instructors and stuff.
Just a suggestion. I don't know if you have that many students ready to go for the advanced class, but maybe that could change to the 330. I don't know. Can we take the advanced class if we haven't finished 330?
Yeah, that's a good question. Yes, you can. In fact, we're going to try to be super flexible right now with this whole deal. Okay. So if you were in the basic, if you were in 330, right, and the thing canceled out, and if you want to jump into 331, jump into that thing. And if you pass 331 just fine, and you feel like, what, I think I got the basics between what I did in 330, what we've done in this class, we can do a petition and get you credit for that 330 class. Part of the reason that I'm teaching the skill and speed development class this summer is so that I have students who are in engine repair class, and their engine was close to being completed. And so I want to give them an ability to complete that class and kind of test out, so to speak. So we're going to be doing a lot of that, like test outs and petitions and stuff, so that you guys can get as much stuff done as you can. So don't worry about the prerequisites. If your counselor or somebody actually has a question, just email me and I'd be happy to work with you. We have our normal automotive counselor, Heather Hughes, Shane Van Gisbert. He's on our part of our home base. He's like another counselor. Those folks can get a hold of me. But what we're going to try to do as a department is be super flexible so that you guys can get through this program as quickly as possible. Unfortunately, some of the logistics that I ran up against was like finding an instructor and then finding a time slot. And so the schedule is
Mhm.
really, it's not really what I wanted. But it was like the best compromise with what I was dealt. I would have liked to run more. At the time we put it together, they said, well, you can only have X a number of people in the shop facility to try to enable you to have the social distancing that we needed to have at that point. So that's where we're at. Now, I will say this is if everything, goes as good as the president and the governor feel like it's going to, right? Like Gavin Newsom said just a few days ago, he expected schools to be back to normal by summer. If that's the case, if we're that level of as far as vaccinations and all this other stuff, and they loosen up the restrictions, then I could add, as long as I have the instructors, I could add some more classes back into the schedule. Okay. But for right now, I don't know if I'll be able to do that. So this schedule, like I said, it was the best compromise. It's not perfect. Some of it was social distancing. Some of it was instructors. And then the other ugly thing is also our budget to run the classes. Like we have less funding in the school district and college across the state overall. So I think you'll see, just, a lower percentage of classes just because of a funding issue too. So if they give me the green light, you better believe I'll be adding some more classes to the schedule. Even if I don't get to add more classes, don't be afraid to ask for, ask to see if there's anything you can do with, as far as a petition or a way that you can get credit for doing it, for a class. Like for years and years, we've given students, like if you're ASE certified in an area, you can use that ASE certification for a test out for one of our classes. Now you can't test out of everything, but the college, I think they have it where you can test out, like you can get petitions for like 16 units worth of courses, and get those applied to your degree. So there's processes to do that stuff. So that was a really good question. I want you guys to know that we're gonna work with you, and we appreciate you guys hanging in there with us. So
We appreciate you. That's a handful of accomplishments, and it's going to be a good one no matter what.
yeah,
That's for sure.
What's going to happen is you guys are going to finish this thing up, but in like in about two to 3 years, come like 2024, 25, you're going to want to come back and take like a performance class or something, because by 2024 we're supposed to get a whole new automotive shop, and we're working on having a super flow engine dyno and some really cool toys in this new shop. So I'm looking forward to that. And that big new building campaign has been coming along really, really good. So anyways, that's going to be exciting. So keep a couple classes in your want to do list at some point, so you can come back and play with us here in a few years. So
I understand that building is going to pretty much take up that whole parking lot. They're going to tear down the existing classrooms, and it's going to be an amazing thing.
Yeah, it should be pretty cool. What they're doing is they're going to take all of tech ed and put us all in one building. So like electronics is going to be right down the hall, and so will the design hub, and so will welding will be at one corner, and automotive will be at another corner. So it'll be pretty darn neat. We're actually going to lose a little bit of space in automotive, but we're going to be able to use our space so much more efficiently. I'm really looking forward to it. It's going to be pretty awesome. So anyways, all right, I'm going to go ahead and
thank you, Mr. French. Thank you, lead chair.
Thank you so much. Yeah,
you rock.